In this question, we have simultaneous equations, but x and y are powers. But we can still use that kind of concept to try to, to try and get where we need to. Because when we have simultaneous equations, we always have x and y in in both equations. There might be times by something, of course. But here we've got 3 to the x and then 3 to the y plus 1, whereas over here it's 3 to the y. So here's the thing, we've got to try and write it them both in terms of 3 to the y. And we can do that because 3 to the power of y plus 1 is actually 3 times 3 to the y. Essentially, I've undone adding the powers. I just separated it out. And that is equal to 5 root 3. And I can do exactly the same. Over here, it's going to be 3 times 3 to the x plus 3 to the y is equal to 3 root 3. And we're not actually interested in finding x and y. We're just interested in finding 3 to the x plus 3 to the y. And if we add them together now, then in fact, 3 to the x plus 3 times 3 to the x is 4 times 3 to the x. And the same goes over here, 4 times 3 to the y. And adding these two surds, 5 root 3 plus 3 root 3 will be 8 root 3. Now I just need to divide through by 4. 3 to the x plus 3 to the y equals 2 root 3. So something that looks very, very, challenging. Actually not so bad if we separate the powers and then just treat it like we do with normal simultaneous equations. B.